National Electrical Code Article 314.17 does not apply to this particular installation. National Electrical Code Article 314.30 requires 6 American wire gauge or larger bare copper for grounding. The #4 copper solid wire is larger than 6 American wire gauge. This satisfies the code requirement. Most manufacturers would agree that the knockouts are intended to mount the panel. There is not a specific code requirement directly addressing this specific mounting method. This leaves it up to the inspector to determine if the installation is safe and complies with the manufacturer's installation instructions. Since there are no specific instructions from the manufacturer addressing this particular installation method, it can be argued that the installation is safe and compliant with the National Electrical Code and applicable ETL standards. Consider the following points to support this argument. Firstly, the hole is located on the back side of the panel. Secondly, the hole is not larger than the ground wire itself. Thirdly, the ground wire is appropriately secured. Fourthly, the panel is securely mounted to the wall. Based on these points, it is reasonable to conclude that the installation is both safe and compliant with relevant electrical codes and standards. To elaborate further on grounding and bonding requirements, it is essential to understand the purpose of grounding. Grounding ensures that in the event of a fault, such as a short circuit, the electrical current has a low impedance path back to the source. This low impedance path allows the overcurrent protection device, such as a circuit breaker or fuse, to quickly trip and to energize the circuit, preventing electrical shock and fire hazards. The size of the grounding wire is determined by National Electrical Code Table 250.122, which correlates the size of the ungrounded conductors to the size of the grounding conductor. In this case, since a #4 copper wire is used for grounding, it is likely that the ungrounded conductors are of a size that requires at least a #4 copper grounding conductor. The grounding electrode conductor, which connects the grounding electrode, such as a ground rod or water pipe, to the grounding busbar in the panel, must also be sized appropriately. National Electrical Code Table 250.66 provides the requirements for the size of the grounding electrode conductor based on the size of the service entrance conductors. It is crucial to ensure that all grounding connections are made properly and are mechanically secure. Loose or corroded connections can increase the impedance of the grounding path, reducing its effectiveness. Antioxidant compounds should be used on aluminum conductors to prevent corrosion. Grounding and bonding are not the same thing, although the terms are often used interchangeably. Grounding refers to connecting the electrical system to the earth, while bonding refers to connecting all metal parts of the electrical system together to create an electrically conductive path. Bonding ensures that all metal parts are at the same potential, reducing the risk of electrical shock. National Electrical Code Article 250 provides detailed requirements for both grounding and bonding. Specific sections address the grounding of electrical equipment, grounding of electrical systems, and bonding of metal enclosures and other conductive parts. Some additional factors may influence the acceptability of using a mounting hole for the grounding conductor. Firstly, the local electrical inspector has the final authority to interpret the National Electrical Code and approve or disapprove the installation. Secondly, if the panel is listed by a third-party testing laboratory, such as Underwriters Laboratories, the listing may include specific instructions or limitations on how the panel can be installed. Thirdly, it is always a good practice to consult with a qualified electrical engineer or other expert if there are any doubts about the safety or compliance of an electrical installation. To further clarify the requirements for grounding electrode conductors, consider the following points. Firstly, the grounding electrode conductor must be connected to a grounding electrode, such as a ground rod, ground plate, or metal water pipe. Secondly, the grounding electrode must be located as close as practicable to the electrical service entrance. Thirdly, the grounding electrode conductor must be protected from physical damage. Fourthly, the grounding electrode conductor must be continuous, without any splices or joints. To elaborate on the bonding requirements, consider the following. Firstly, all metal enclosures containing electrical conductors must be bonded together. Secondly, all metal parts that are likely to become energized must be bonded together. Thirdly, the bonding conductors must be sized appropriately according to National Electrical Code Table 250.102. Fourthly, the bonding connections must be made in a manner that provides a low impedance path for fault current. In addition to the National Electrical Code, other codes and standards may also apply to electrical installations. These may include local building codes, state electrical codes, and industry standards. It is important to be familiar with all applicable codes and standards before performing any electrical work. The NEC is updated every 3 years, so it's important to use the latest edition. Electrical inspectors use the NEC as their guide for ensuring safe electrical installations. When in doubt, always consult with a qualified electrician or electrical inspector to ensure that the work is done correctly and safely. Also consider the specific application. A residential electrical system has different requirements than a commercial or industrial system. The size of the service, the type of loads, and the environmental conditions all affect the grounding and bonding requirements. For example, a hospital or other healthcare facility has more stringent requirements for grounding and bonding due to the sensitive electronic equipment used in these facilities. Another factor to consider is the presence of sensitive electronic equipment. Sensitive electronic equipment can be susceptible to damage from voltage surges or other electrical disturbances. Proper grounding and bonding can help to protect this equipment from damage. Surge protective devices, or SPDs, can also be used to protect sensitive electronic equipment. SPD are designed to divert voltage surges away from the equipment and into the grounding system. The NEC has specific requirements for the installation of SPD. It is important to select SPD that are appropriate for the specific application and to install them correctly. When working with electrical systems, always follow safe work practices. Firstly, always to energize the circuit before working on it. Secondly, use appropriate personal protective equipment such as gloves and safety glasses. Thirdly, never work alone. Fourthly, be aware of your surroundings. Electrical work can be dangerous, so it is important to take precautions to protect yourself and others. In summary, the installation of a #4 copper solid wire through a mounting hole in a load center panel may be acceptable, provided that certain conditions are met. It is important to consider the applicable codes and standards, the manufacturer's instructions, and the local electrical inspector's interpretation. When in doubt, always consult with a qualified electrician or electrical inspector to ensure that the work is done correctly and safely. Remember that electrical safety is paramount, and it is always better to err on the side of caution.